Hello, everyone.
Hi. So, hello everyone. By a show of hands, who have participated in a data migration project?
All right. Keep your hand up if it finished on time. All right, as we guess, not many of us. And it's reasonable. Migrations are one of the most complex engineering tasks. They are risky. We handle with real data and real traffic. They tend to have, they have potential for data loss and incidents, and usually they take more time than planned. So, nice to finally meet you on stage. My name is Roy, but everyone calls me Noyman. In the last 2 years, I'm working as a backend engineer in the ecom platform company. Kudos to ecom. And we are here to talk about data migrations. So just FYI, the longest migration I had and my team had took almost 7 months.
And I'm Avraham. I'm quite a while at Wix. I was in premium contacts, now in data streams. I've participated in several migrations, and the longest one took 2 years.
Wow, and we thought at ecom that 7 months was a long time.
So what we're going to talk about, we are going to recap on some migration concepts. What is a migration? We're going to share the challenges we faced, and we have some insights on how to overcome them, and hopefully the next migration you do will be on time.
All right, so let me give you an overview of the situation. Let's say you have a service, it implements some API, let's call it V1. It binds to a database, and there is some client that calls this API. What you want to do, and for some reason, you now need to create your V2 API. We'll talk about the reasons later. So you sit down with your teams, you have a design review of the V2 API, you bind it to a database, and now what is the migration plan? So let's just copy all the data from the source DB to the target DB, and then ask the client to reroute the traffic from V1 to V2. Sounds simple. Well, at first glance, it is. But what if there are multiple clients that are using your V1 API? All right, it's still achievable, right? You will contact all the clients, ask them to reroute the traffic, so you just copy the data, route the traffic. But then, while identifying all the callers of your V1 API, you also found some other weak services that are calling this API. In some cases, these services are not part of your domain, not part of your company. So now if you want them to reroute the traffic, you're now dependent on their time and their schedule. What if your V1 API is public, thanks to Roisha? So now you need to ask external developers to do this change, to reroute the traffic to the V2 API. And this is something that is a little bit more complex, right? On top of that, your V1 service and system handles real traffic, real users with all the businesses that depends on it. And sometimes your database is huge. You can't really copy all the data in an instant, so this is more complex. I hope that you are convinced by now that data migration is not a simple task, but if not, think about the events that your V1 API emits and are being consumed by other services or other third parties via webhooks. So you don't even know who consumes these events. Remember, this is about our users' trust. We can't afford any downtime and no data loss. And now that we are aligned, the data migration is a complex task, let's talk about the reasons when do we do migrations. So there are many reasons. Some of them, like compliancy, you need to encrypt some data that is not encrypted in your V1. Scalability, you are expecting a future traffic that your old infrastructure can't hold. Velocity and technical depth, it just slows you down, or some other business requirements that you now need to follow. In some cases, it's all of them together. Which brings me back to this diagram and this complex data migration. And Avram, we need a system to how to do migrations in weeks. We don't want to reinvent the wheel every time, and we want to minimize the data incidents in the future. So what can we do?
May I present to you the migration playbook. the Nile team have created a way of doing migrations in a standard way and in a predictable way. And I'm going just to recap on it. The first thing you do, you remodel your domain. You write down your new APIs, you design your new system. And then you plan the rollout. It's very important to do that because if you figure out how the users and when the users will use it, that will going to change the way you implement it. And you have to do it before you start writing any code. And then you implement your new system. Well, you ask Claude to do that. If you followed all the steps, we are here. We have the old system with its database. Let's call it from now on V1. And we have the new system with the respective database. And for simplicity, let's go from now on V2. The next step is to implement backward compatibility with your old API, meaning you expose the new version of the new version of your API to the old users of the API in a transparent manner without they knowing. So going back to the diagram, the way to do it is routing all your traffic to the API proxy. The API proxy is a special kind of server developed by the Nile team that simply forward all the calls to your original service. But it also allows you to, when you decide to convert the calls to V2, both the requests and the responses. And this part of the logic is that something that you have to write. Additionally, the proxy also consumes your V2 domain events and allows you to convert to V1 events. This closes the loop without the different clients, and then it allows you to transparently move the traffic without anyone knowing. With the API proxy in place, the next step is to roll out to the new users. So going back to the diagram, what we need to do is to create a population that you contain the tenants, or in this case, the sites that are already in V2. And then the API proxy conducts a feature toggle that checks if the site is in the population and then routes the traffic to the V2. If it's in the population, if it's not, it goes to V1. Quite simple. So now that the new users are using V2, you run it for a while, you gain confidence and see everything is working. Well, it's time for the data migration. And how we do that? CDC, that's it. Not so complicated. Well, let's say you have your old database. So in your old database, you have all the rows that are currently in the database. We call it the snapshots. So you connect the CDC connector to the old database, and it scans the whole table, and it produces every record into a Kafka topic. And then you implement your migration service that consumes all the records in the Kafka topic. You then write code that converts each record to the new format and saves to the new database. And this phase is called the eager migration. And while the eager migration is running, changes are happening in the old database, and the changes are accumulated in the bin log. And then, by the way, CDC stands for Change Data Capture. It's a standard practice in the industry. And the next step, you connect also the CDC connector to the bin log. It loads each record in the bin log to the Kafka topic in the same way, in the same format. The migration service consumes it, you convert it, and save to the new database. And this is called the lazy migration. By the way, the lazy migration continues until all the changes have been consumed, and it goes on. As long as you have changes in the old database, it continues to work. Now that you have finished migration of the data, you can finally roll out to the existing users, meaning all users are gonna get the version. How you do that? It's very simple. The API proxy stops conducting, and everything goes to V2. And all that is left is to decommission the old system, and you go here, you get rid of V1, and you ask everyone to move to V2. And we are done. We can go home now.
20 minutes ahead of time, but we're not done yet. Well, indeed, we gone a long way. Now we have Nile, we have the playbook, we have API proxy and CDC. We have very good, strong foundations. But still, even today, data migrations are complex. So we are here today to present you some challenges and solutions of the places where the playbook is not enough. So listen carefully, because we're going to dive into them. So let me start with the first challenge. So as Avraham explained, CDC is a record-based migration approach. It means that it works well with databases, that each entry in the DB is an entity. What if this is not the case of your source database? For example, have you ever heard of event source technology? In event source databases, every entry in the DB is just a change that happened to an entity, which means it's not a one-to-one relationship, but a one-to-many. If you want to understand what is the actual state of an entity in this kind of database, you need to combine all the historical events of this entity and calculate the actual state of it. So in these cases, we have a solution. We can use eMigrator. eMigrator, I guess most of you are familiar with, is a tool that works that are designed to handle mass data processing of a large list of IDs, usually, and in this case, meta-site IDs. So the change here in compared to CDC is that eMigrator is a site-based, and that's the pivot. It's not a record-based, but a site-based. And you probably migrate the full site state once. Use eMigrator when data is not entity-based, or you want to migrate by meta-site. It's bringing me to another issue. So have you ever saw a UUID with, doesn't work, but a UUID with Chinese characters, or a very, very long first name, or someone just filled up more than 100 emails, although you have a limitation of 10, or there is a birth date at the year of 19653. I don't think Claude is going to leave it this year, but these are all examples of corrupted data. And think about it, the fact that when looking at your V1 API, you have validations for such cases, which means it should never happen, but still, these are examples we found in our databases. So invalid IDs, data that do not comply with V1, over the limit string or lists, and many more bugs. Remember that your legacy services carries years of changes, and they can be surprisingly corrupted. So what do? We can have a read-only dry run of our source database. What does it mean? It means that it's going to give us visibility of the dark spots of our database. What do we need to do? So we implement the migration service, a very limited implementation, just bind it to the source database, and we expose logs of raw data or some insights from our data. We can think of different data types or nested structures or translatable fields or anything you suspect. And in this case, you are probably more familiar, in this phase, you're probably more familiar with your V2 API because you just made a design and implement the portal and everything. So think about the places in the design, the moments where you discuss both systems and you find differences between them. All the suspected spots, you want to log this, and have visibility on them. So what do you need to do? You implement the service, just the read phase and the events, the logs. Then you set up a connector. It's easily done via dev portal. You let the snapshot dry run begin, and you end up with a very nice dashboard that gives you the visibility you want. For example, in our case, in the shipping migration, we wanted to make sure that all the countries, all the destinations in the V1 API are addressed in our V2 implementation by the destination resolver. You will have visibility of all the problems from your domain, your V1 domain, with almost zero setup. It's really, really easy. Next up, so let's look at this diagram. So as you can see, we have two identical shipping address of Tel Aviv, and they call our service V1 and V2 which calculates the delivery rate. Okay, so it gets the Tel Aviv address, and in V1 response we got a valid rate of $10, while our V2 API responses with the address not supported error, which means we have a parity gap. Parity gaps can be out of many reasons, but some of them missing functionality, action events we forgot to expose, different validations that are different between the systems, and sometimes we have bugs in our implementations, so some V2 bugs. We want to identify all the parity gaps ahead as fast as we can, so we can move on, because we can't roll out to new users or existing users with bugs. So what do we do? The first thing to do, and this is the easy part, we can run the V1 test suite using the API proxy on the V2 implementation. It can be done locally, and it gives us test confidence for the differences of the use cases between V1 and V2. And I promise this is the only Claude prompt you're going to see, but we had to have at least one. So the second thing you can do is a quad QA. You can just ask Claude to analyze the actual usage of your V1 API, the actual production usage, find use cases, and then create a plan based on the production analysis and your code base, both V1 and V2, tests and logic. This way, you will identify all the parity gaps, and you'll be able to fix them. Let's go back to this diagram of the proxy. So we fixed all the parity gaps. We found all the corrupted data, and we're now aware of them, and we know how to deal with them. And when the API proxy is in place, we just want to make sure that the actual existing users' production flow and traffic goes to V2 without failing, right? So we did it locally. We asked Claude to do some QA plan, and now we want production traffic, real traffic, to go to V2, but without impacting the users. It's still risky. So what do? API proxy provides us with a compare mechanism, which in every read call to your V1 implementation, it sends another async call to V2. The V2 response is being compared with the V1 response, and you get your match and diff score. So this is the actual, and by the way, just to emphasize that, the user doesn't know about it. It still receives the V1 response and the V1 data. So you have this great dashboard by the API proxy with, as you can see, with the match and diff score. You can see most diffs per site and many other insights of your parity status. In addition, my teammate Uzi Cohen also provided a great visualization tool for comparing between V1 and V2 responses. It gives you everything that is different between these two responses. And it's already production. You can access it from the previous dashboard. So it's great. But now, Avraham, I'm sorry, I'm confused. So we said at the beginning, we need to migrate all the data and limit the parity gaps and all the things that we fixed. And now we are in the compare phase, but we found bugs. So what do we do now?
Yeah, so before I show that, so if you want to do a compare mode, if you do it after you migrated all the data, so you already migrated all the data, spend all the time, sometimes months, and now it's too late. So you want to do a dry run on a subset of your data. Went to the Nile team, and it was impossible. But then, thanks to the contacts team, and especially Dov here, we found a hack. We did that actually after the migration, because we found ourselves having to fix subsets of sites again and again, and we couldn't afford to run the whole migration again and again. So, and this becomes very handy to also do a dry run before. The way to do it, you go to our source database, and you talk to the DBAs. Now you can do it in a dev portal. You can create a table with the sites that you want to migrate. And then, when you create your CDC connector, you can provide a query with this simple join that will just migrate only the sites on that table. And now you can do a dry run with a subset, turn on compare mode on the same site, gain confidence, and then move on to your full migration with much more confidence.
All right. Let me give you a spoiler for the next topic Avram is going to talk about, and it's really, really important one. He's going to talk about how long your migration is going to take. But before that, we need to talk about this issue, the partition level locking. So to those of you who are not familiar with Kafka, in case one of the messages, for example, number 203 message is corrupted, and your handler, your consumer, the migration service fails, then the rest of the messages are stuck. The pipeline is stuck. In such cases, think about your plans. You wanted to spin up the connector, let the snapshot start, wake up in the morning, drive to the office because we don't work from home anymore, and ask Claude or analyze yourself the issues in your compare dashboard and fix them. But now, just a single record, it can be the first one or the last one, but a single record can ruin all your plans. Why is it actually happened? Because CDC preserve order per partition, so in case one of the messages fails, the rest of the messages fail as well. So what do we do and how can we handle that? By the way, when Avram and I talked about it, we had different approaches, so we tried to sum up the best approaches for this issue. The first one is we do nothing. We want the safe path. We keep it blocking retries, so whatever message fails, everything is stuck, and we need to manually fix the handler and move on. This is if you want to, this is if data consistency is your high priority, so you don't do nothing. The second approach is the fast path, and it's a try, catch, skip. So you try to do the operation, the migration. If it fails, you log some events, some BI metric if you need, and you move on. You finish gracefully. The pipeline will continue. You wake up in the morning, look at the logs, and then you will decide what you want to do. You can wait for the end of the migration, you can exclude these sites, or you can just fix it and rerun migration on specific sites. And the pro path is using a DLQ. So when you use the DLQ, the failed messages are being pushed to some queue, then you can fix it whenever you want, and you can just replay these messages.
So, that leads me to the question, how fast your migration needs to run. So maybe 2 years is okay, I don't know. Maybe you want it 2 days. So I'm assuming that we want to run a migration as fast as you can, but without everything exploding. So let's say Avishai gave you a credit card with $5 billion, and you can spend $5,000 every single minute. Without calculators, how much time will it take? Shout. Huh? 100 days. Hundreds of years, okay, not so much. The answer is 694 days, almost 2 years. And that's what would happen if we would have 5 billion records in our database. And we talk to the DBAs and say, okay, we want you to be safe, don't explode the database, you have live traffic, don't go over 5K. We negotiate, and then maybe you can go a bit higher, but in the end, those are the numbers for if we are running at these speeds. But then, if you remember, the CDC migration have eager migration and lazy migration. And actually, we only took into account the eager migration, the number of records, but we forgot something. The same database have 15K RPM changes all the time, on average. That means that on average day, we have around 22 million changes that happens. So during the days that we are running the migration, changes are being accumulated, and then you have to handle the changes, and then that's how much it will take. If you can see, I'm covering it. That's how much it will take with each velocity. Like in the 5K, it will take almost 3,000 days. And we don't want to do that. We want our grandsons to run the migration. We want us to see it finished, right? So, but we also forgot another thing. While we're handling the changes are still happening. So if you migrate on a low rate than the changes themselves, so you are not going to finish the migration ever. So that leaves us with only really two, you could take a year, but only two practical paces that you want to run your migration. But how to do that? So if you remember, also from the same diagram, the first thing that the CDC migration does is produces all the records to Kafka. But it actually produces the messages, like Noyman said before, into partitions. So these partitions allows for some parallelization. The thing is, after the messages are produced to the partitions, I'm now in the data streams team, people come to the channel and say, oh, help us speed up our migration. How we do that? We say, too late, you already produced all the messages. You have to start again. So you have to set the partitions up front. In order to do that, you probably need to do a write run. So you calculate an individual partition, what's the pace, how much time it takes to process, and simple math, you can calculate how many partitions. In the case of contacts, it was 350 partitions were needed in order to run on 100K RPM. But what about the database? Like I said, went to the DBAs and said, okay, you can only do 12.5K RPM, and then the migration will never end, as you remember. So after some negotiation, they agreed we can have the strongest and the most expensive machines on our arsenal, and it will be double the pace, and it will finish maybe in almost 10 years if we don't have to run it again because we find a bug. And it was not practical. So what we did, as a side note, our database in our old version was suffering also, and we were already spending a lot of money, but our database was very heavy on writes, and the disk space was almost finished, and we had to find a solution. And after many years or weeks, it's a dream come true. We finally implemented sharding. We didn't implement it. The DBAs, the DB core, SDL teams, and other infra teams worked very hard, and they gave us the sharding solution. We could now split our database in smaller and happier little databases that allow us to serve much more traffic. Like in contact sales, we did 8 shards, but if we have 8 shards, in theory, we could add more shards, rebalance in the future, and have infinite scale. That really allowed to run our 100K RPM and finish on time. But what if the migration have to access other systems? Those other systems have also limitations. Some are known and some are unknown. You're going to find out when you start migration, and people come to you and say, stop your migration, you are running everything. Because when you do a migration, you access other system, and they have databases, and they have events, and they have other things, and things can explode. So you'll be stuck with whatever lowest limitation in the system you have, and we wouldn't be able to do the 100K we want, and we go for 5K and run the migration forever. So that's very simple. Don't do side effects. The way to do it is, instead of accessing the other systems, you have a BI event, you produce to Kafka, and you have a lower rate, and if needed, you do another migration later, so you reduce your blast radius. Well, almost done. I was thinking with Noyman if I should bring it up, because it's like a very rare edge case, but I went for including it. As you remember, when when rolling out to new users, you have a populator that has to add each tenant or site to the population manager. But what if in your site creation flow, something calls your API? And because something calls your API inside creation flow, and also site created adds the site to the population, well, here you are. You have a race condition. Actually, even without a race condition, the population manager is eventually consistent, and then you cannot guarantee you're going to get the right one. To summarize, it took us some time to solve it, but the solution was to add a aspect in the site creation flow that we're talking about that is creating a member for the site owner. It means the contact that exists on site creation. We add an aspect, and it forces the proxy to select the right version for that site. And that's it. Now we're done.
Wait, just a second. Let me be a boomer again. Sorry for that. We're not done yet. But if you got this far, so celebrate. Coincidence or not, 2 great migrations just finished last week. And it's Contacts V5 and Discounts V2. Remember we talked at the beginning about how long our last migrations were. So Avram said 2 years, I said 7 months. So discount migration.
Not this one, the previous one.
Yeah, the previous one,
better.
of course. And this discount migration took almost 4 weeks. So it's great improvements. And now for the actual fun and the last milestone of your project, which is the cleanup. So there are a couple of things we still need to do. And the first thing is traffic. So make sure there is no traffic for your V1 API. Make sure it's totally dead. And after you do that, you can kill the service, remove the pods, and get rid of it. The second thing you need to do is you can remove the code. We don't want to keep code that we don't need. So be a good citizen, remove the code, and make sure to be really cautious with proto packages because we don't want incidents after we finish the migration. Third thing to do is deal with your population. So population storage and conduction costs money. So if you don't need it, delete it and move on. And the last thing, which is probably the most risky one, drop the database. You don't need this data anymore. You have it in your V2 database. And basically you're done. And remember that all this will save Wix money. And if we want to save money, we won't have tokens for Claude or any other AI tool. What's next?
Well, so we're thinking when we did this migration that when we do migrations, you have to do a lot of things, a lot of manual work. So you have to do dry runs and fix bugs and PRs and rerun and go. And so what if maybe an agent could do that? Okay, we didn't start planning anything. We did talk with the Nile team, and they are thinking about it, and they are starting doing. I know them, so I think you're going to have some kind of tool that handles most of things soon. Let's see. So to sum up, migrations are not optional. We have to do it. No way around. Just plan for the messy parts, build the things in a safe way, do cleanup, and celebrate.
Last but not least, we really want to thank our teams and teammates from Contacts and from eCom. We couldn't be here without you, and you made all the migrations successfully together. And of course, to all the infra teams that helped us a lot and save us a lot of frustration and answer every thread we had in CDC, channel or API proxy discussions. So thank you all, and thank you for being here today, and enjoy the rest of the conference.